Chebyshev theorem. What is it about? Well, Chebyshev will tell you the amount of data between two values. Let's call this x low and call this x high, and this is my variable x, and this is my distribution shape. So Chebyshev will tell you the amount of data here. I'll tell you how much data you have between x low and x high. Like, suppose I have 40 students in my class. How many students got, a score in quiz 1 between, let us say, 3 and 7, for example? How many students? How many? Are they 30 students, 20 students? How many? So Chebyshev will be able to tell you. Okay, so what is the information? Chebyshev needs to know only two things: the mean, the average, and the standard deviation sigma. Okay? So in this case, just giving the mean and the standard deviation without knowing anything about the shape of the distribution. We don't know, is it going to be right skewed, left skewed? I mean, how does it look exactly? We don't know anything, just the mean and the standard deviation. And from here, the Chebyshev can tell you that the amount of data here. How much is this amount? He said this amount, in fact, is 1 minus 1 over k squared. Okay. So what is k? K, in fact, is equal to the high value minus the mean divided by the standard deviation. So we just use this value here and the mean and the standard deviation. We don't need this? Yes, we don't need this. Why we don't need the x low? Because in fact there is a condition here, which is the distance between the x low and mean is equal to the distance between the mean and x high. Yani this distance here is equal to the distance here. So this is the first limitation of the theory, that the lower value and the upper value for which you want to get, the number of elements here, or the data ratio, then they have to be at equal distance from the mean. The mean should be exactly in the center between the x low and the x high. So that's the first limitation. Okay, so again, what is this distance here? If you look at this distance, x high minus the mean. Well, that's really x high minus the mean. So if you multiply the sigma times k, then x high minus mu equal to k sigma. So this distance, in fact, is equal to k sigma. This distance is k sigma, okay? And this distance is also k sigma. This distance here, from here to here, is k sigma, and this distance here to here is k sigma. Okay, so that's coming from this equation. So we can say also that x high is in fact equal to the mean plus k sigma. This is equal to, okay, let's do that in a different color. Okay, this is equal to mu plus k sigma. So that's another way to think of, this formula. Another way to think about it is like that, okay, because x high is actually the mean plus k sigma, while x low, if you think about it, x low, in fact, x low is the mean minus k sigma. Minus k sigma in this case, because it's the mean minus this distance, and this distance is k sigma. So anyway, I'm just giving you this variety because some students memorize this formula or this formula. In fact, no need to memorize it because it will be given to you in the exam. And some students, in fact, memorize this formula and they need it a lot. So anyway, I'm just telling you that this is coming from here, this is coming from here, so one of them will be enough to know the other. Okay, so now what is this ratio? What is this value? 1 minus 1 over k squared. Does it represent the number of values here? No. In fact, it represents the ratio. This is the ratio, proportion. So if these are 30 students and the total students is 40, the ratio is 3 over 4. So this is going to be 3 over 4. And you see that 3 over 4, that means the ratio of the students, not the number of students. So we don't know. Chebyshev theorem does not use the number of values here, the data size. It's not counted into the consideration. So this will be actually a ratio here. So this is what Chebyshev can tell you. The ratio of the data between lower value and upper value is 1 minus 1 over k squared. Another limitation of the theorem is that it's actually the minimum ratio. Chebyshev doesn't know exactly this amount. He knows that this amount is at least 1 minus 1 over k squared. This is the minimum it could be. At least, for example, suppose I calculated and I found it to be 30 students. So that's 30 out of 40, which is 3 over 4. 3 over 4, this is the minimum ratio. It could be more than 30 students. Maybe 34, 40, 32, 31, I don't know. So he's not able to tell you the exact amount. He's telling you the minimum amount. And that's why the theorem say what? The theorem will say this is at least 1 minus 1 over k squared as a ratio exists here, okay, between this lower value and the upper value. Okay, if you want the percentage, of course, you can multiply this ratio by 100, and if you want the exact number, you need to multiply this ratio by the total number of data sites. So the data size is 40, and this is 3 over 4. 3 over 4 times 40 will give you 30. So anyway, that's the Chebyshev theorem in general. Okay, what it say is that it's telling you 1 minus 1 over k squared, okay, proportion of the data exists between x low and x high, okay, where all of them, well, these two are at equal distance from the mean, one above the mean, one smaller than the mean, and the distance between x high and mu is k sigma, and from here you can get the k. Remember, the sigma will be given, okay, the mean will be given and the sigma will be given in these questions, and then usually you need the k, so you can get it from this equation or from this equation. I think we need to see examples to understand this better.